Hello everybody, today we're going to look at this counting problem from Brilliant.org. I will have a link to the problem in the description. It says, how many 5-digit numbers can be formed if either every successive digit exceeds its predecessor, which basically means the digits are in strict increasing order, or every successive digit is smaller than its predecessor, which means that the digits are in strictly decreasing order. And of course we can't have the leading 0, so the first digit has to be 1 through 9 basically. So I'm going to count these separately. So first we're going to look at A. And so we have 5 digits, and whenever I'm doing a counting problem and there's digits or seats or whatever, I like to just write blanks. It usually leads to more organized counting. And so we want every successive digit to exceed its predecessor, which is going in this direction. So basically we have 5 numbers in increasing order. And the last of these, or the smallest of these, has to be greater than 0, because you can't have a leading 0. So we can think of some example numbers, let's say like 1, 2, 4, 6, 9. I guess we should also note that this last number has to be less than 10, obviously, because it's a digit. And or we could start with something greater, like 5, 6, 7, 8, 9. And we try to think about how we can count all of these numbers. And the first thing to note, depending on the first digit, right, you could have more possibilities. Like here we went from 1 to 2, but really we could have gone from 1 to 3 or 1 to 4, so on. But here at 5, there's only one number that starts with the digit 5, because it goes 5, 6, 7, 8, 9. That's increasing order. If at any point we went to a higher digit, then it would have messed up. We couldn't have gotten to 9 here. This is the only increasing sequence that starts with 5 and ends in 9. So what we should be thinking about is the differences between, the numbers. And so specifically for this example, let's say we're going from 0 to 1, that's a +1. And then we're going from 1 to 2, that's a +1. And then we're going from 2 to 4, that's +2, and then +2, and then +3. So really we have 5 numbers here, and that gets us to 9. Here we have +5, +1, +1, +1, and +1. And so this is sort of an in-between number, right? 1, 2, 4, 6, 9. This is the maximum number. And if we look at the smallest number we can make, which is 1, 2, obviously 1, 2, 3, 4, 5. Here we have a sequence, and it's +1, +1, +1, +1, and +1. So here, all of our pluses, that gets us to 5. Here, all of our pluses, let's see, we have, that's 9. And here, all of our pluses add up to 9. So obviously, the sum of all of our pluses is going to get us our last digit. But what's important is that we know that the pluses, since this is the smallest number, we have to end up with at least a 5, and we can only end up with at most a 9. So the sum of these numbers is bounded by 5 and by 9. And so we have, say, A plus B plus C plus D plus E. Between 5 and between 9. But what's important to note is that for some sequence of these pluses, there's a bijection between these pluses and the number we produce. And that's pretty easy to see because we make a new digit with each plus, and the important thing is that it's exceeding, so it's strictly increasing, which means that each of these A, B, C, D, and E are positive integers. You can't have a 0 because if at any point I had a plus 0, then I would get the same digit, and that's not good. So now we want to count how many of these A, B, C, D, and E we can have. Well, if you're familiar with any counting, this should look like stars and bars, which is a technique for counting basically sums. But the problem is we can't directly use stars and bars because these are all positive variables. We need non-negative integer variables. Well, how can we do that? Well, if a number is positive, that means it's greater than 0. And if a number is non-negative, then it's greater than or equal to 0. And from here on out, I'm going to write non-negative integers as a sum letter with a prime, just to distinguish. So here we have a positive, and it's greater than 0. But then we have greater than or equal to 0 for non-negative. Well, our greater than or equal to case for the positive number is a is greater than or equal to 1. Then we know that a minus 1 is greater than or equal to 0, which implies that a minus 1 is a non-negative integer. So what we can do is subtract 1 from all of these positive integers, and we'll get non-negative integers. And so we can do just that. So we're subtracting 5 on both sides. So now we have 0 is less than or equal to the sum of 5 non-negative integers. And so also here, we're creating a bijection between positive integers and non-negative integers. And now we can use stars and bars to count this. And if you haven't seen stars and bars, I'll demonstrate it now. So let's say we have the equation a prime plus b prime plus c prime plus d prime plus e prime. Let's say we're doing the 4. Now what this means is that, well, basically we represent each plus as a bar. So we have 4 pluses, so we have 4 bars. Now in between all the bars are non-negative integers, which represents a star. Basically 1 star for like 1. So let's say we had 1 plus 2 plus 0 plus 0 plus 1. So to the right of this bar, right, we have a 1, so that's 1 star. And then we have 0 stars, 0 stars, 2 stars, and 1 star. So we're trying to count how many ways we can write 4 as the sum of 5 non-negative integers. Well, that's equivalent to arranging the 4 stars and the 4 bars, which is just a spelling problem, which is just counting how many ways can I spell in like rearrange the letters of a word. Let's say where a word is just a sequence of letters. AB, AA, BBB, A. What this is equivalent to, counting the number of ways to arrange these objects, is the total number of objects, which is, in our case, 8. Choose the number of one of the objects, basically. Well, this only works for words with 2 letters, or 2 different letters. So 8 choose 4, and if you don't know what the choose function is, I'm not really going to explain it much, but essentially we're just counting how many ways we can arrange 4 stars and 4 bars, which is bijectively equal to the number of ways to have 5 non-negative integers that add up to 4. So that's 8 times 7 times 6 times 5 divided by 24, and this comes out to 70. So that's one of our cases. So we see that we have a prime, like the sum of these non-negative integers equals 0, 1, 2, 3, and 4. Those are 4 different cases, or 5 different cases. And so the total number of ways to add up, basically we're turning this inequality into a set of values, because if we're adding up integers, we're going to get an integer. So we're looking at the integers that are between 0 and 4 inclusive, which is just 0, 1, 2, 3, and 4. And so the number of ways we can do this, which again is equal to the number of ways, or the number of numbers in this part A, the number of numbers with strictly increasing digits, is therefore equal to 4 choose 4 plus 5 choose 4 plus 6 choose 4 plus 7 choose 4 plus 8 choose 4. And I'm getting all these numbers from the fact that you add the number of pluses to the number you're trying to equal. So this is 4 plus 0, 4 plus 1, 4 plus 2, 4 plus 3, and 4 plus 4. And we're always going to have 4 pluses, which in our case is like the number of B's in our word. So we're always choosing 4 of our objects. And this comes out to 126. And that's only part A of this problem. So now we want to count the numbers where they are strictly decreasing. So that would be like 5, 4, 3, or not even, that wouldn't even be the smallest one. The smallest one would be like 5, or 4, 3, 2, 1, 0. Because now we can have a 0. And this is going to change things the way we count, but not a tremendous amount. So again, I'm going to have these bars, and we're going to have strict decreasing, and again this is less than 10. So we can still look at the differences between each digit, or between each pair of digits, consecutive pairs of digits, anyway. But here, this first plus, as we see here, can be a 0. But the ones after it have to be positive. Now what that means is that our smallest possible case is a 4, but now our biggest case is still a 9. But so we have a non-negative difference here because we can have 0, but we have positive differences everywhere else. So this is the same as saying A plus B plus C plus D plus E prime falls between these boundaries. And again, I'm using the prime. This is why it's nice to denote that this is a non-negative integer, whereas these other four variables have to be positive. So we can do the same trick where we subtract 1 4 times to get every variable into a non-negative integer. So we can use stars and bars again. So if we subtract 4 on both sides of the inequality, we get that 5 is less than or equal to the sum of the non-negative integers is less than or equal to 0. And this is pretty much the same. The first four cases, 0, 1, 2, 3, and 4, are the same as this one. So all we have now is 4 plus 5, choose 4, which corresponds to the case where all of them add up to 5. So we have plus 126 is the number of, was this part. We have the same sum, but we just have an extra term. So we just have to calculate 9, choose 4, which is I believe that comes out to, that also comes out to 126, funny enough. So the total number will be 126 plus 126, which is 252. So for A, how many 5-digit numbers can be formed if every successive digit exceeds its predecessor? That's 126. And if every successive digit is smaller than its predecessor, that is 252.